I think so.
Great. Good evening, everyone. Tonight we're going to have Fernando talking about Code World, which is a project that teaches students in grade school things about math and physics using Haskell as a medium to teach them. And Fernando has been deploying this at scale. So give us first feedback.
Okay, thank you. So my name is Fernando Alegre, and I'm in Louisiana at Louisiana State University at the Kane Center for STEM Literacy. And mainly my job is to create curriculum and courses for high schools. I test them with some students, I train teachers, and I try to organize the whole thing with very little people helping, but I'm trying to do whatever I can. So let me put this a little in context. So in LSU, we are trying to develop what we call graduation pathways, which are a set of courses that we want to fit into the elective courses for high school. So that they typically have like 2 electives each year for 4 years. And we try to fill them with courses related to pre-engineering, digital media, biomedical sciences, or computing. And one of the things that just by, I don't know, coincidence, we came up with is let's have one course that is in the middle, that is common for all the pathways, and that teaches computational thinking and also 21st century skills. So at the time I was around, and I thought that maybe I could do it in Haskell because it's supposed to be a very foundational course so that the students learn the very foundations, and they connect it also with math, because one of the requirements that we had is that actually the math scores in many cases in the schools in Louisiana are pretty low, and this could be an opportunity to actually try to help them in that area too. So in these pathways, all of the pathways have some programming, but as you see, it's a variety of them. We have Scratch, Python, JavaScript, Java, C, C++, and there's a lot of JavaScript in digital media, but there is also Haskell in the middle, and in particular, a simplified version of Haskell, which comes from Code World. So, so we have been expanding, and every year we are covering more area and more schools in Louisiana. We have been mainly supported by the Louisiana Department of Education and by the East Baton Rouge Parish school system. And then this slide is what we show the teachers who want to participate. So who can teach these pathways? Anybody can teach the pathways. So we are trying to find teachers who are energetic and willing to do these kind of things, and then they come and suddenly they need to learn a new programming language, And in most cases, in almost all cases, it's not just learning a new programming language, it's learning programming, because they have absolutely no background in programming. So this has been, and also some math. Surprisingly, you would think that the teachers, even the math teachers, would not have, I don't know how to say this, but you would say that they would be, the math part would be easy for them. And it's easy for them as long as it's in the context of the high school math. But what happens in these kind of courses is that suddenly you have to apply a lot of math that you know, but you didn't see in a different context, and suddenly it is a challenge even for some teachers to come up with that. So the integration of the math and the programming at the same time, learning to think computationally, it's been a challenge not only for the students but also for the teachers, and in many cases because the teachers are required to understand it to a point that they can actually teach it. It's been more challenging for the teachers actually than for the students. So in particular in the computational thinking course, we have 6 weeks of training, which is very intensive, from 8 a.m. to 5 p.m. The teachers they have to do all the exercises just like if they were students. Many of them are very puzzled. Usually the first week goes well, and then suddenly everybody freaks out. And they say, this is impossible, I cannot do this. So there is a lot of hand-holding to convince them that actually, yes, you can do it. You can actually work through it and finally get through the whole course. And actually not only you can learn the course, but you can actually teach the course too. So so far, these numbers are kind of complicated because there's more teachers trained, but then there are many other circumstances that come into play. Some of them are math teachers, and at the end, the administrators don't let them do computing. They put them into math classes only. So it's complicated, but we have been kind of growing, doubling the number of students, but not doubling the number of teachers. So so finding the teachers is getting the more challenge here, because once they at the beginning you see they see this nice thing, anybody can do it, and then they are thrown into this 6 weeks intensive training. Some of them start to think about that. But on the other hand, we got some support from the government, from the US, the National Science Foundation, and the US Department of Education. So this was completely unexpected. Last spring we applied for these grants and we got them. So now we have more money, but we have more to do, because now in particular, the one that is more interesting for this audience is this one, the middle one, because it's a study of the Introduction to Computational Thinking course, which is the Haskell course in Code World. And we actually promised that we are going to see that it works to make students learn math along with code. So we have 5 years and $4 million to prove it. And we probably will need some more help, because we said we are going to do a control study with control groups. Some of the students are going to learn this. Some of the students are going to learn engineering. So we are going to compare whether if you learn engineering compared to coding makes a difference or does not make a difference. We also have a third control group that they will not do neither engineering nor coding. And then we are going to compare all three. And actually, we are going to look at the standardized math test scores, the number of students who enroll in AP math courses and AP computer science courses, and see also in these 5 years, we have time for doing one longitudinal study to see whether actually they are the number of students who get interested in computer science and actually get into college thinking that they want to do computer science increases. So we are promising a lot of things here, but we believe this has to work, right? So by the way, this is just on the side, but one of the things that we had in this grant is that we needed a software developer to help with moving some of the training online so that the training in situ is not as long as it was. So probably we cannot afford anybody in this audience, but if you know someone who wants to move to Louisiana or work in some states, I actually asked whether they could work in remotely, and they said as long as it's in a right-to-work state, whatever that means, you can. I just checked in Wikipedia, and New York is not one of them, but still, if you know someone, we may need some help too. So the results of this study will be added to the What Works clearinghouse. So let me go there. What Works clearinghouse. So this is a website maintained by the US Department of Education, and it says what works. So you search for math, for example, and you say what works in math, and then if this, so and then they list every single study that they funded with this money, and then you say, okay, what about cognitive tutor algebra 1? Does it work? Well, the study meets the standards. How does it do? Positive effects. Okay, so what about in general mathematics achievement? No discernible effects. So this study is going to be one of those listed there, and they are going to say yes or no. So it's kind of a, according to the US Department of Education, it's a high priority, high stakes study. Okay, so, and then I lost the, okay, so what we are studying is the first question there. Does the LSU curriculum that uses functional programming in CodeWall work? This is what is going to be in the What Works clearinghouse, right? But, well, I don't know how specific people are going to quote that. Probably many people are going to say, yes, does CodeWall work, yes or no? Does Haskell work, yes or no? Or does functional programming work, yes or no? Because so far, it's the only study that is going about functional programming and definitely about Haskell that is going to be in the What Works clearinghouse. So, there are other studies that have been done in the past, that they are not in the What Works clearinghouse. For example, Logo, it was famous because it was proved that it does not work. So surprisingly, because I think it could work, right? But probably the problem is that many of these studies, even though they were associated with a curriculum, with a particular curriculum, and they were associated with a particular way of pedagogy, at the end, what everybody remembers is just the platform. Does the platform work or doesn't work? So probably the particular study that they did with Logo, with the particular pedagogy that they used and the particular curriculum that they were teaching did not work. But what people remember is Logo doesn't work. Okay, so Scratch, for example, it's surprising because many people are doing Scratch, but nobody is doing a What Works clearinghouse study for Scratch that I know, or they were not last time I checked. So because Scratch somehow comes from Logo, right? So it's a derivative of Logo. So it's a very high, it's a risky endeavor if you go and say, well, we have a precedent here, and now we have to overcome that precedent. So I guess at some point there will be studies about Scratch, and you heard?
Yep. Why did they conclude that logo does not work? What is wrong with logo? Could you repeat the question?
Yeah. The question was why does logo does not work? Well, it's complicated. What they said is that they made a study, a control study, it was, I don't remember the first name, but it was PEA, and then they said they could not see any significant change compared to the control group in the particular pedagogy and the particular course that they studied. Of course, one of the things I think, in particular for logo, that was the problem, is that the Papert, the pedagogy that he had, he said, well, it's constructionism, and it's mainly let the students explore freely and try to build their mental model just by exploring with the code. And that probably was too unguided. Actually, what I found is that such an unguided exploration probably it's very difficult for the students to come up with their own mental model without more guidance. So probably, if I had to say something, but I didn't do the study, I would say that logo did not work because that particular pedagogy was not constraining enough for the students to guide them towards the path. But that was a big blow to logo at that point. Probably things could be done in a different way, and at some point there will be other studies, and maybe the conclusion will be different. But at that point, that was what happened. So the other languages, I don't know of any other study that actually is trying to do this connection with math. The one that works, on the other hand, is Bootstrap. Bootstrap was proved to work. And it was kind of the opposite from Logo, because the Bootstrap curriculum is actually very guided. So this is a curriculum, is a 17 hours, I think, curriculum in Scheme. So it's also functional programming. So this actually, they made a study, and it seems that they could see some difference. It focuses on word problems. So they have word problems that you can actually solve by creating a function, like if I go at this speed, when I will reach the moon, things like this. And then you can write your function and check the time and the distance and solve the problem by just running the function. And actually, it seems that it made a difference. The students were able to solve word problems better after working with Bootstrap than before working with Bootstrap. So this is actually a very encouraging thing. On the other hand, the study that they made, they didn't do it for the What Works Clearinghouse. It was a study that was not supported by the government. So that doesn't mean that if they did it, maybe they would find the same thing. But the study is not in the What Works Clearinghouse. And then another problem is the scheme syntax is kind of unpopular, especially in people who didn't see it before. Once you get accustomed to it, it's pretty nice, right? But at the beginning, people are not very willing to go into that direction. And then the third thing is that the Bootstrap had a very limited scope. So they proved that something worked, but what works is they had to limit the scope a lot to make this claim, right? So it works, but it needs to be very focused and very guided and very narrow on this word problem solving. So what I would like to do, or what I'm trying to do, is extending this Bootstrap kind of system with more content. So actually, that's why I call the course Computational Thinking, because I want to broaden the scope, bring some math, bring also some computing, and then I thought the Haskell platform, and in particular the code world, was a much better fit for what I wanted to do. Actually, I find code world very nice to work with. I mean, and one of the things, the most important things that it has is it has zero need to install. So you can go anywhere, to any school, and you don't have to deal with the IT there, you don't have to ask for permission, you just go to the website and it works. And that's a plus for going to schools. Anytime you have to ask to the IT for something, things will slow down a lot. So there are some alternatives. Actually, I was considering at some point also Elm, which is also a nice little language, right? Very well adapted to what I wanted to do, which is basically as close to pure lambda calculus as possible. But even when I was trying, this was like 3 or 4 years ago, when I was trying, a new version of Elm came, and then suddenly my programs did not work anymore. And I had to throw them out and start from scratch because they changed the complete way that it was organized. So at that point, I was kind of seeing whether I would go with Codewall or with Elm, and I said, no, this is a mess. I need to wait until it stabilizes, because otherwise I'm going to have to redo a lot of stuff. At the end, I ended, even in Codewall, redoing a lot of stuff, but that's a different story. But and then I noticed recently that the people from Bootstrap, they created a new language called Pirate, which is like a combination of Python and Scheme. I think they had a version that runs, no, I think it runs in JavaScript now. I think they made an interpreter of Pirate in JavaScript. But it kind of combines supposedly the best of both worlds, right? Because Python, one thing that Python has is that people find it very easy, at least at the beginning, and then it combines that with the functional programming, which is a much better paradigm for transmitting these kind of basic ideas. But let's now focus on code world. So surprisingly, or maybe not surprisingly, but the teachers love it. I mean, literally, they say, we love it, we love it. So it seems that they are very happy with it. I had 2 teachers, and that's part of why I'm losing teachers here, because they liked programming so much that they left teaching. So, and then someone told me, someone made a master thesis about, a teacher made a master thesis, and it seems that in her class she was doing code world one year, but the next year they switched her to computer science principles in JavaScript or something like that. And then some of the students had taken the computational thinking course, the previous course, and then they said, wow, we want code world, and they started chanting code world, code world, code world. So, so I mean, because I had this idea that, and that's the first thing that you always hear also. When they say, in what language is this in computational thinking? And then I say, in Haskell. They say, Haskell? Whoa. But, so there's a lot of, at the beginning, nobody wants to, what is that? This is not Python. Why not Python? But once they start working on it, and they start doing stuff with it, people really like it. It's surprising, but all the reactions that I have are very positive. And I'm going to show you later some work from the students, and you will see that the students go crazy sometimes. That doesn't mean that the projects that they do are very elaborate. They are kind of beginners projects. They are very simple, but still they put a lot of time and effort on them sometimes. Okay, so one of the things that Chris made for Code World is he simplified the prelude. So when you look at Code World, so the first line there, translate, X, Y, rotate, it would be some kind of normal Haskell that you would see, no? Or maybe with dollars, you would have the second one, right? But actually, in Code World, you would write the third one. So even though it's Haskell with using the proper syntax of Haskell. The Haskell is so flexible that you can actually simulate arguments between parentheses just by having tuples there. So it's just a function applied to a single argument, which happens to be a tuple, and now it looks as if it was a function with several arguments. And that's actually very powerful idea. And it's very nice because then you can save this tuple as a variable, and then you can apply the function to the tuple. I mean, you can do a lot of things that you usually do in math without thinking. You can do them in Haskell too, just by this little trick of having your list of arguments as a tuple. So at the beginning, I found it weird that this doesn't look like Haskell, but actually it's very nice when you start working on this kind of things. But he opened the can of worms, so I started to experiment and going a little further than that. At some point, he had to add this message there because I added a standard library there so that the students who use my server in LSU, they need to import the standard library, which is basically the name I gave to the prelude. But since in the Code World website, the standard library is not there because the prelude is implicit. So the students started complaining when they just connected to the regular Code World. They started complaining, my code doesn't work anymore. It doesn't work, it doesn't work, it doesn't work. So this particular picture, I received it like 2 days ago from a teacher saying, and this is not to criticize the teachers, but to express that users at this level, they don't read error messages. Nobody reads error messages. Because he sent me this image and said, I don't understand, but one of my students has a problem, and I don't know what the problem is. So, of course, the problem is that the student was using the wrong server. So I started making some changes, basically as people complained about things. So the first thing that people complained very, very, very loudly, so all the teachers in the training said, no, absolutely not, was list comprehensions. So in particular, this is more or less what one of the teachers, and that teacher, she loves Code World, but she said, but this list comprehension, it looks like a for loop, but all these symbols that you don't remember what it means, it's impossible to read it. I cannot remember what the bar means and what this arrow means and what these symbols means, and it makes it very complicated when I'm teaching to have to stop and say, oh, what was that? I don't remember. While, for example, in Python, I would write something like that for R in range, whatever, circle. And then I don't have to wait to think, what is this? So I guess she was right. So what I came up with is a function that I call overlays that basically builds whatever function you pass in the first here, whatever function you pass in the first argument, oops, sorry. It makes 1, 2, 3, 4, 5, 6 up to the number that you give on the second argument. Yes?
So I'm curious, the list comprehension syntax actually looks a lot like set comprehensions from mathematics, but I guess
yes.
you teach those until like pre-calculus or whatever.
Yes, yes, yes.
Was this a teacher who had that math knowledge or not?
No, actually, that teacher has a background in business.
Okay.
Yeah, because there's many. So supposedly we are training teachers who come from many backgrounds, but even for math, it depends on what. Because some teachers actually studied elementary math, and then somehow they ended up doing high school math, and they are not so familiar with the set comprehension either. So yes, for anybody who actually knows a little math, yes, you see that and you say it's exactly like the set comprehension, right? Because it's for x in whatever such that x belongs to whatever. But for someone who does not know set comprehension, that does not help. They feel completely lost. So these overlays, on the other hand, they seem very intuitive because you just do circle 1, 2, 3, 4, 5, 6, 7, 8, 9. You're done. So actually, people are using this and they don't have much trouble. So This is basically an example that I go step by step about the kind of exercises that I do. So you want to create a star, and then you start with something like this. Can you see this? So you just create 3 points, and then a polygon ABC, just the triangle, right? So then the next step is, well, you rotate the triangle 90 times 1, 90 times 2, 90 times 3, 90 times 4. And actually, we try to tell the students that this is the way to do it. Don't do the math in your head, because then you become the computer, and then you don't need a computer, but then we don't need this class anymore, right? So don't be the computer. Let the computer compute. So these are the four rotations that you need, and then we go and add a function. Oops. So what happened here is this point 1, point 2, point 3, point 4, which were variables, now becomes a function. Point of 1, point of 2, point of 3, point of 4. So this is why I like this Haskell so much. You can make a variable into a function by just putting a parenthesis there, just like what you would do in math. It's the same thing, the same concept, right? So the variable 1, 2, 3, 4 becomes the function of 1, of 2, of 3, of 4. So then you can generalize. Well, it was redundant, right? Because it was 1, 2, 3, 4. You just need only one case, the general case, so you have now point of n. So this is kind of the progression. This is what the Bootstrap people call the design recipe. But the design recipe, instead of having like a separate worksheet for doing the design recipe, here it is integrated in the system. We are doing the design recipe by working within the system itself. So the next step, so now we added variables, so now it's no longer, you see, it's turn times n, so that we are preparing for doing any kind of turn, not necessarily 90 degrees. So now the number of points is 4. We divide by the number of points. Still, we have here point 1, point 2, point 3, point 4. But this is exactly what the overlays is. So the next thing is going to be is replacing this point 1, 2, 3, 4 by overlays. So so we go here and we generalize. And now we have these overlays. And then at that point, we can put any number there, and it's going to work. Okay, so this is very nice, because instead of having to have a separate system to do this kind of design recipe, you can use the system itself, the code wall system, to make this design recipe and evolve the program from the variables and from the quantitative at the beginning to the variables, and then to the functions, and then to the loops. So we have everything there in a progression that goes quick, very smooth. Okay, so let me try to go to the present mode again. Okay, so, but I'm going to jump out of the presentation mode again, because now I have another one that says, well, the second thing that people started saying is, but I want some randomness in my drawings. I want to make a drawing, but I want something random. And I don't want to have to learn a lot of complicated things to do that. I just want something random in my drawings, that's it. So, so then what I did is I created a new entry point called random drawing off, just like the drawing off in code world, in the standard code world. So this is an example of how it works. So instead of saying drawing off, we say random drawing off, and then instead of being a static picture, it's a function of random. And then this is a list of random variables, which comes, this is a very little adaptation to the standard code world, but then you have random 1, random 2, and actually this became very interesting because the number of random variables that you have here are the degrees of freedom of that thing there. So it's the number of independent variables. So actually, it lets you make the connection to independent variables and degrees of freedom very easily, because these random things become the degrees of freedom there. So, so this was actually pretty interesting. And now I lost track again, or where I am. Okay, so yes. So the next problem that I found is one of the exercises that we do is building a clock. So I'm so, okay, sorry. I'm clicking at the wrong, okay. So it's making a clock like that. Okay, so this also uses the random drawing off there, so if you click on it, it changes the time randomly, because it has here random 1 and random 2. So there's 2 degrees of freedom in this clock. The 2 variables change, one for the controlling the hour, the other controlling the minute, and then you have the function clock here. But of course, people said, but this is ridiculous. I want a clock that shows the time that it is now. That's what clocks do. I want a clock that shows the time. So let me first close, because I'm going to start running out of memory or CPU, I don't know. So okay, so then I have to import the do library. Okay, so I didn't want to go too much into, well, the do's, so I was thinking how could be the least intrusive way to do this, and I came with this. So yes, there is a do, and I have to explain that when you want to do interaction with the outside world, you have to use this keyword do, and then the interaction from the outside world comes with this kind of arrow. A little symbols there I cannot avoid, but well, you just say what the time now is this, and then you draw it there. And I guess that's the time, right? It's 8. Yeah, the time is that clock. So it shows the time now. So so this comes from the import extras do. So if you don't import this line, you cannot use the do. That was also built into CodeWall. It was pretty nice, because I just realized that you have some kind of implicit monad there that it does it in the context, right?
It uses rewindable syntax.
Rewindable syntax, yes. Rewindable syntax, that's what I mean. Yes, so when it does the rewindable syntax, I could just hide it here in the library, and then...
Be happy next time you pull from the base repository.
Sorry?
You're not going to be happy next time you pull from the base repository.
Oh, you remove it?
It's going to give you an error whenever you use a do keyword, because it assumes that students didn't need to do that.
Oh, okay, okay, so they are going to be very unhappy because now they cannot show the time. Yeah, so this was a request that people made. So they want to be able to see that this connects to the real world somehow. Yeah, maybe for middle schools it's not so important, but for teachers, this was a request from the teachers. So the request from teachers, I take them more seriously than the request from students. Because to students I can say no, but if I say no to teachers, I lose teachers. So, so this was actually a request from the teachers that they wanted to, well, but this, can we use this for something real? So at least can we show the time? It's not asking that much, right? So it was easy. Hopefully there will be some kind of workaround. And of course, once you have that, it was not difficult to also have some input. So with just adding a prompt there, so you can now ask input Fernando, and now it says Fernando's clock. Okay, so so this is the most that we do with the do library. But it's still a little nice that you can actually enter some input from the user, and then the drawing that you get has some input parameters from the user and from the time or from some external effects. I already covered this. Something that I also added was the sliders. So you can actually control the sliders and make. And this is actually something that also illustrates the degrees of freedom. So the modeling part is the part that I'm most interested in, because it's the part that the students really don't understand so well. So this is with the random feature that I had. I found that the students sometimes were confused, because even though I see that this has 2 degrees of freedom or 3 degrees of freedom, the students could not identify the number of degrees of freedom, and then they didn't know how many random variables to put there. And sometimes I think the sliders help better to see what happens when you change one of the variables there. So, so actually, I made this after I saw that just having the random theme is very nice, because it makes you easily have drawings, but on the other hand, sometimes it does not illustrate so well what are the degrees of freedom. But I tried, this was difficult, because I wanted something that is as less intrusive as possible, because every time you go into more complicated things, people are not going to be happy with it. So, so for at the end, what I did is, so you have this slider. So you create the sliders there. What can I do to larger? How do I make it larger? Oh, the control plus, sorry. You meant larger you could not see, sorry. Okay, can you see now? Sorry about that. I was kind of, yes. So the sliders, create the sliders. These are the positions, and these are the labels of the sliders. You have to go a little around the story, so this, you cannot translate this. That's something I'm not completely happy with it, because this happens out of the main thread. But then the order of these 4 sliders gives you 4 numbers, and then you receive those 4 numbers as a list there, and then you can operate on them as variables. You can read only them. You cannot write to them, but you can read them, and then you can draw anything depending on what you receive from those variables there. So for this is as little intrusive as I could come up with, that gives you some interaction and also allows you to read variables from the sliders from the input. So you don't have to create the event loop. You just need to create the sliders and then read the variables. But then once you have sliders, you can go back to have random boxes. So some of them can actually be random, and some of them can be sliders. And since the sliders use the 0 to 1 range, so when you move the slider, it uses the 0 to 1 range, and then you have a width conversion function that converts the 0 to 1 range to whatever range you want, so that it actually shows here the correct converted value. It doesn't show 0 to 1, but whatever comes from this function, it also receives that conversion value from here. And then, since the random number also goes from 0 to 1, you can exchange them easily, and then you can have either random things or sliders. And then, why not? We could also have some timers, and then we can have some random things. While one is changing over time, you can adjust this, and you can just randomly move the other. So, and this is, as you just change slider for timer, you're done. So this is very non-intrusive. That's the point. You could do, yes?
What's your experience using this with kids in class? Do they get it? Do they really struggle with this, like, pass a list here, get a list there?
So I started this year to try, and very slowly. So not very few people have tried yet. So I made a few experiments here and there. They understand what is going on if you give them this, and then they can play with this part, and they can start building this. This, I'm not sure yet, but I cannot find of an easier way to have some interaction. I mean, not just in Haskell, in any language, right? What less you could have than just saying what's the position and what's the label and how to convert those values. I mean, I don't think that's something that could be done more easily in any language. Or maybe I'm wrong, but I couldn't find. I mean, if you want to have some interaction, definitely I've tried with some people, more grown-up people. I have a couple of students from education who are actually learning to code with this code world also. I just put them on the same kind of curriculum. They are adults, but they are learning. They didn't have any trouble with this, no trouble at all. But the kids, I don't know yet. I mean, I know that some novices don't have trouble with this. That's actually the example that I showed you here, this example with the sliders, this was made by this student. So actually, for grown-ups, and that's the thing that I'm trying to cover here too. So I'm interested in the kids, but I'm also interested in the teachers, or in general in the novices, people who don't know how to program, and they want to get into some coding experience, and I want to make it as simple as possible. And my real clients, my real customers are the teachers, not the students. So the students are the customers of my teachers, the teachers are my customers. So I want to make my teachers happy. My teachers want to make their students happy, but I want to make my teachers happy. So, and the teachers, they seem to, these kind of things, they seem to manage okay. Actually, that student that teacher student, who made this master thesis, she used these sliders also. And it seems that it was okay for them. So that's another thing. So I want the teachers to create assignments too. I don't want them to depend on me creating assignments. And I want them to have some freedom so that they create something. And for that, it's also important that they have some control. So they may want to do some sliders to show some particular properties to their students. And I want them to be able to do those kind of things, because it is important for them to take ownership of this as much as possible. Okay, so now I'm getting probably more controversial. And this has not been tested yet. This is something that I'm thinking about. So another thing that people say is, especially people who know, right? Because the novices don't know. But I've tried this with also with advanced students who knew Java and JavaScript and Python and whatever, and they say, we hate it. So the only group who actually hates code world is people who know other languages. And one of the complaints that they say is that the syntax is much worse than object-oriented syntax. So, for example, I'm going to show you the typical, this is a novice code, but this is the typical wall of code that novices write. So, the problem with this is that it's very difficult to read. And it's not only difficult to read, oh, maybe it's difficult to read because I didn't make it bigger, right? Now it's difficult to read still. Because the problem, yes, this follows the math, semantics, and syntax, and that's nice. But the problem is that what's the translation associated to this? Now I have to navigate all the way until here. So the numbers associated to the functions are very far from each other. So when you have several nested functions like this, you lose track. Even if you know what you are doing, you lose track of what parameter goes with what function. You just lose track. I lose track. So it's not just that the students lose track. I lose track when I check this kind of code. So it's very difficult because of that. There's also the difficulty that, well, making loops would simplify a lot here. But even without that, the fact that the arguments are very far from the functions is kind of a problem. So I took advantage of one other change that Chris made in CodeWall, because he removed the dot. So the function composition. So let's put it back. But let's put it back not as function composition, but as function application. So now the dot means function application. And now you have this nice thing that says solid rectangle 26, paint light blue, up 7. This is so nice to read. You can, first it goes left to right, as it should. Right? Because first you make a solid rectangle, then you paint it light blue, and then you move it up 7. And then the locality of the parameters, this is the part that I like the most. Because now you can see everything, it goes with what it belongs. So this is pretty nice to read. So then the only thing that I was thinking is, how do I make loops here? Because this particular student had this grid here, right? So the overlays work well when you have just one dimension. But for 2 dimension, it becomes nested overlays. And that's very messy. As long as nested loops are very, very messy always, nested list comprehensions are messy, and nested overlays are also messy. So I was thinking how to do it, but then this actually makes it kind of easy, because this clap function here, I name it like this because this is clone and apply. So what it's doing is basically the iterate thing, right? So it's iterating down and creating copies of down as it iterates, right? So it's cloning and applying down to a sequence of numbers that starts at 0.5 negative. It goes by 2.5 each time, and then I take three of them. Yes?
I mean, couldn't the main point actually just be addressed by putting the numbers first in the argument list?
By putting the numbers first and the argument then, well, maybe.
Yeah, like in standard Haskell order, they typically would be. I think that change was made because without partial application, there's not quite so strong a case to put
Yeah, yeah. Maybe that could work. I still think this is pretty nice to read.
What happens when you make a mistake? That looks like it's going to lead to the worst error messages in the world.
Well, yes, but people don't read error messages. They don't read error messages. Even when it says you are connected to the wrong server, they don't read error messages. That's a fact.
Isn't part of the idea of teaching computational thinking that you teach people that they should read error messages?
Oh, yes, yes, yes. I made a lot of fuss about that. It doesn't transcend. It doesn't permeate. Yes, 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 yes. It is important to read error messages, but it's like a wall. You don't get that message across. The message that you get across is, and that was a very nice addition. If I just do something here, then you get this. Oh, that calls the attention of everybody all the time. So this is very good. Actually, it reduced the number of errors dramatically. Everywhere, the teachers, the students, it went like boom to the floor. So from last year to this year, when I changed I updated your version. Last year I didn't have this. This year I have it. I saw a dramatic change in the number of errors. But error messages, it doesn't work. That's what it says. Yes?
If our functions aren't curried anymore and they're just on tuples, how does the dot work?
Okay, so
These are different functions.
okay, so the functions are curried
So like
behind the scenes.
they're new functions
So
that are curried?
yes.
Okay.
I mean, I thought they would work just like
Let me see if this is the correct.
so instead of finding the last argument, you find the first.
Okay, so this is the definition. So even with parentheses, you can recurry things. So this is going back to the curry, yes, but keeping some of the arguments together because sometimes it's convenient. There is an explicit check in code wall that you cannot do this. I bypass it by putting parentheses and parentheses.
So dot is actually flipped function application.
Yes, yes, it is flipped function application, yes, yes.
Could you maybe use like a type class instead?
Well, the point is that I want to teach at least the teachers this, that this is not magic. I don't want to say this is something that is magic behind the scenes. I want to have a lesson that says, let's build this. Let's define this operator, and then let's build this. It's just functions. It's functions and with operators, with no extra support from the system, and that's why this is just a regular file in the system. It's not something that needs support from the compiler. With what you know, which is just pure lambda calculus, you can do this. Type classes will not work in that context. Yeah.
Did you see that Pirate also did this?
I looked very little at Pirate. Do they do this or not?
Yeah, they call it the cannonball operator.
The cannonball operator.
Dot, but it's the same.
I see. So maybe we are all converging to something that works. And that would be a good thing because it needs to work, right? And it should work. I think this is a logical idea that comes from, this is still math. The good thing about this is that there's nothing magic, there's no special compiler support. There is only sometimes the compiler not allowing things that it should allow. But you can bypass them with parentheses, right? Yes?
I think this is really interesting. One of the moments that I enjoy most when I'm working with math teachers, and I realize not all of your teachers are math teachers, but when I'm working with math teachers, one of the moments I enjoy most is when I say, okay, here we're really going to harp on the fact that when you're evaluating an expression, you have to work from the inside out. And the teacher's eyes light up, and they're like, yes, that's an idea that we need to get across, that when we're evaluating a math expression, we work from the inside out.
Yes.
And so this kind of seems to not, say, okay, yeah, but here's this other way to evaluate things that's different from the way we do it in your algebra classes. And I'm not sure what I think about that.
Yes, yes. Yes, this is not supposed to replace the other. It's supposed to move forward. So what I'm thinking is how to move forward from there. And I'm thinking about, for example, students who are more advanced that say, well, this wall of code that I have to write is very inconvenient. And also, I think this is important to understand that many of these tricks that you see in other languages are actually not something that is separated from math, that is still math. It's a clever arrangement of arguments that you do in math, but it's still math, right? And also, well, not with the dot, but with the space to say, in algebra later when you start talking about matrices, you do these kind of things, right? So you have A, B, C, or AX, or things like that, with not parentheses in the middle or nothing like that. It's more like the typical application like that. So it's not something that you need to hide. Probably it's not the first thing that you should see either. But it's something that as long as the language allows you, if the students actually can do it, and if they understand, I think there's a lot of thinking that is going to go around to make sense out of something like this, right? So, but this is, I don't know yet. This is something I'm going to test at some point. And then, last thing that I have been thinking is what to do about state. And I don't know, I don't have a clear idea yet. I have 2 attempts. I'm not happy with either of them. So there's the standard attempt in Code World, right, with the activity of, right?
I'm not sure if everyone here knows the standard code world stuff.
Okay, so the standard Code World stuff is an activity of that actually it's a loop, but you know it receives you have the loop. I'm tripping myself. You have to define a function for initializing, and a function for updating, and a function for drawing, right? And in the updating function, you receive events from the system, right? Like the key presses, the mouse presses, or the time periodic events. And then you can use those events to update your state, right? You receive also the previous state from the system. You update the state, and then you have a draw function that draws the state. So, so that's basically the loop that is there. This is not different. I just try to make some adaptations of it. So in this one, what happens is I use the same kind of sliders, but now the sliders can actually update. So the only thing new is I have a with update function here that basically takes, and this is, I'm not so happy with this because it takes a list of values like this before, but it's a little hacky because you have to specify how many variables you have there, right? So you have as many variables as widgets, right? And then once you give a name to the corresponding index, so this is basically 1, 2, 3, 4 is the indices, then the state becomes whatever the hashtag. The hashtag is the way in Code World to index, to access a particular position in the list. So this new hashtag vol py accesses the number corresponding to the state new at position vol py. But it kind of reads nicely, because then you say if all time is less than new time, then the new ball py, the new position is going to be, because this is set in the position, is going to be plus the velocity times the increment in time. So, so it kind of reads nicely here, but it's a little hacky. The good thing is that you can see the sliders moving, or you can stop the time, or you can make the ball just stop by changing the slider there, and then it stops, or it goes very slow. Or so it's kind of interactive, but at the same time, it's evolving. And the only part that you need to modify is the widgets here. You just define a conversion function and an updating function, and then everything kind of works. The second attempt that I'm trying, so why I'm trying these attempts? Well, because I had, with the regular event loop, I had a meltdown of teachers. So some of the teachers melted down. They just quit. They said, this is too difficult for me. This is something. So there was some barrier there that I encountered. So I'm trying to find a way to move forward. And every time I see we need to go slowly, right? Because I see that most courses that teach computing start with for loops. And what I've seen is that people don't understand loops. I don't think this is the proper progression. Once you know how to program, you think that it's very easy. But before you know how to program, you really need to go very slow. And this event loop, even though it is very natural for us, is not natural for people who don't know. So there is a jump there that I still don't know exactly how to scaffold properly, but I'm trying to find some way to make the progression a little better. So, so now where is my ball? Okay, so this is a second attempt, and this is what is happening here is that I'm hiding a context. So this is similar to an event loop, but it has some context that is hidden. So the real event loop is hidden, and then I make them just work with the state. And I was trying to get something that, again, follows some kind of natural syntax. So you have a setup and a draw function here, just like in other systems like P5 or things like that. And then you start with an initial state, and then you say on key up, increment py, on key down, increment whatever, on time change the time. I'm not sure if this is something that is going to work or not yet, but I'm thinking of ways to scaffold a little this progression, because at some point it gets complicated. But before that point, I see that people are very enthusiastic. There is a barrier there that I still need to work on how to smooth it out. But I think we are getting there, and hopefully at some point we will get there. But I would like to see if you have ideas or anything about that. And also, how could we work on this? How do you see something like this happening somewhere else? How could we organize and connect better? Because I think this needs to work, and I think it should work, but I mean, any help is welcome here. So, so I think in summary, there's a lot of good things that Haskell brings. Probably Pirate brings it too. So there seems to be a convergence here. So this kind of programming is converging into something that probably is going to work. And that's the most important part anyways, whether it's in one particular system or the other. Well, I'm happy with the one I have, But the important picture is that these kind of ideas are converging, and I think they are a good approach. This is in general the challenges that I see in the future. The administrators don't understand these kind of things. It's a complicated thing, but I still think it could work. So that's all I have. If you have any questions. So I forgot to show you some examples. Okay, so this is a baseball match just by doing this random drawing off. So the students simulated all the players moving around with just random numbers. This was pretty nice. I was surprised. And this was a 9th grader. So it was not from a regular school. It was not one of the top schools or anything. It was just a regular student. Then some other people went crazy with animations. So they made a full, I think it's like a 2-minute movie about the Mars lander or whatever. So it goes down. And then it's moving, the parachute. And finally, it deploys there. So this was okay. So if you have any questions, yes.
I was going to ask if you had looked at any other languages for inspiration for the dot pattern. I was going to specifically suggest enclosure. A lot of people use the threading macro.
Okay.
Which is kind of a way to structure a sequence of operations. Or I don't know, in Scala you use an and then, which kind of logically structures things left to right instead of because basically you're trying to get around function composition, which goes right to left.
Yeah, I think my main inspiration was the Java streams.
Oh, okay.
But yes, I could look at those too. Okay, so thank you.